Hi everyone, what's up? Today I want to show you how you can compute a linear approximation using differentials. So today we're going to compute a very specific value, and that is going to be the square root of 145, okay? Now we want to find how much this is, and we're not going to use the typical linear approximation formula, but differentials. So I'm assuming that you have already some intuition into how differentials work geometrically, okay? So I'm not gonna give you any geometric picture, but I'm just gonna, run through all the algebra, okay? So first, we know that we're gonna have an initial equation that is basically gonna tell us the values that we need to find, okay? So we're gonna say that y plus a very small number in the y-axis, which is gonna be dy. So y plus dy is gonna be equal to the function that we have, in this case, that is the square root function. The best function that we can use to find this value is simply, square root, and then let x be equal to 145, okay? So this is gonna be the square root of x plus dx, okay? Basically, the way you can see it is like this. So if you have y as a function of x, just so that you understand where I'm deriving this equation, if you have y equal y as a function of x, and this function is square root of x, and you say that you want y, I'm actually going to use limit notation. So if you want to take the limit as h approaches 0, and you want x plus h, well, this is going to be the same as the limit as h approaches 0 for the square root of x plus h, okay? So here I'm just trying to show you that when we use differentials, remember we're talking about very small numbers of y and x. The differential of y is an infinitesimal of y, it's a very small number of y, and the same thing for x, okay? So you can use limit notation to represent how dy or what dy represents, okay? So in this case we have y is a function of x. If you want to add a very small number to this input x, well, you also need to add that small number, that is, take the limit in the function, okay? So you need to take the limit. If y is equal to square root of x, well, you need to take the limit as that very small number, in our case that would be differential of x, is being added to x, and then take the square root of that, okay? So this is, some intuition into how I got this previous equation, okay? So now let me go back to the problem. So this is the equation that we're dealing with, and now remember y and x is going to be, x and y, they're going to be a point that is going to be a fixed point that is very easy to compute. Now a number that, I would say an x value that will give us an exact value that is close to the real square root of 145 will be x equals 144, okay? And that will be y equals 12, okay? So I'm going to say that x is going to be, remember in linear approximations, we have an x naught point, x sub 0. That point will be fixed. In this case, we do not use 0 notation, but we just simply use x, okay? So we're going to say that x, our fixed point, which is going to be this one, is going to be 144. Remember, this is 12 squared. And that means that y, well, is going to be the square root of 144. I'm just simply evaluating the function, and I should define it actually. I should say that we're playing with y is equal to square root x, okay? So I'm just evaluating the function y at this x value, and this is going to be 12, okay? So now these are the two values that we now have, and we just simply need to find dx and dy, okay? Now it is pretty easy to see what dx is going to be. Remember, dx, the square root of x plus dx will represent the square root of 145, and we already know how much 144 is, so you can create the following equation. You can say that the square root of 145 will be the same as the square root of x plus dx, x is 144, plus differential of x, okay? Now you can square both sides, and you just simply get that 145 minus 144 will be equal to dx, okay? Which means that 1 is equal to dx, okay? 1 is kind of a big value, if we're referring to an infinitesimal, 1 is a small value, but since we're doing linear approximations, well, we really just want to approximate things, okay? We don't really care about the exact value. So dx is going to be equal to 1, okay? Let me make this bigger. So the dx is going to be equal to 1. And now the only value that we need to find, we already have y, x, and dx, we just need to find dy, okay? And that is the differential of y. We know y is equal to the square root of x, so we can differentiate this function and multiply by dx. So remember, I'm gonna write it over here. So the differential of y is gonna be y prime times the differential of x, okay? So we have that the differential of y is gonna be y prime, the derivative of square root x is gonna be 1 over 2 square root x times the x, okay? So this is gonna be the value that we have. Now we already know how much dx is. Dx is gonna be 1, okay? Which is great because we don't have to change anything in this fraction. And we also know how much x is. We know x is gonna be 144, which means that dy is gonna be equal to 1 over 2 times the square root of 144, okay? Which you already know is gonna be 1 over 2 times 12, which is 1 over 24, okay? Now you can see that dy is a very small value, so that gives you some intuition into the scales. Of course, you could divide dy over dx, and you would get a rate of change, which would be the derivative. Without going into in the infinitesimal world, you can find a rate of change for dy over dx, and that would be 1 over 24. So yeah, let's continue. So we already have all the values that we need. We have y, dy, and x and dx. So now we just simply need to plug the values and see what we get, okay? So we know that this right-hand side of the equation will be the square root of 145. So I'm going to write this. So the square root of 145 is going to be equal to y plus dy. Now we know y is going to be equal to 12. And we know dy is going to be equal to 1 over 24, okay? Now, 1 over 24, it's almost the same as if you had 4 over 100. It's very close. I know 4 over 100. Well, you know how much that is going to be. So you can just simply add that value. You could leave it like this, of course. But, well, I think it's better, if you just simply use the decimal point notation. So you're just going to get that this is 12 point, that would be 0.4, okay? 0.4. And this would be the value that we are looking for, okay? Now, of course, you need to be careful because the square root of 145, we shouldn't really say that it's equal to y plus dy because this is really an approximation, okay? So you need this squiggly thing between these two expressions. And now these expressions, you can use an equal sign because this is indeed true, but the square root of 145 is not equal to y plus dy, okay? It's approximately, but not equal. So yeah, this is, another thing that you need to be careful, okay? So yeah, that's been the entire thing. Now you know that the square root of 145, it's very close to 12.04, okay? You probably have some more decimals after the 4, okay? So that's been the entire thing. I hope that you enjoyed this video, you learned something, and see you in the following one. Bye.